Welcome back to all subscribers. Thanks again, and I am very excited and grateful to your consideration. With this lecture, we are going to learn Python script that creates a simple invoicing application using the tkinter library for graphical user interface components. Let's go through the code and we'll try to understand its structure and functionality. Importing various modules and libraries and setting up the necessary dependencies for a GUI application. Let's break it down step by step. From Future import with statement. This line is a Python 2 compatibility import that allows the use of the with statement as a context manager. In Python 3, the with statement is supported natively, but in Python 2, this import is necessary to enable its usage. From datetime import datetime. This line imports the datetime module from the Python standard library. The datetime module provides classes for manipulating dates and times. Import random, OS, CSV, SYS. This line imports the modules random, OS, CSV, and SYS from the Python standard library. These modules provide functionality for generating random numbers, interacting with the operating system, working with CSV files, and accessing system-specific parameters and functions, respectively. Import SQLite 3 as PG. This line imports the SQLite 3 module and assigns it an alias PG. The SQLite 3 module provides an interface for working with SQLite databases. Import typing. This line imports the typing module, which provides support for type hints and annotations. Import tkinter as TK. This line imports the tkinter module, which is a standard GUI toolkit for Python. It provides classes and functions for creating windows, widgets, and handling user input. From tkinter import ttk. This line imports the ttk module from tkinter. TTK stands for themed TK, and it provides enhanced versions of the standard tkinter widgets with a more modern look and feel. From tkinter.ttk import button. This line imports the button class from the ttk module. It is used to create buttons in the GUI. From images import star. This line imports specific image resources from a module called images. Actually, it's in folder with init file which redirect images inside the folder as in module in Python. These images are likely used as icons or graphics in the GUI application. From ttk bootstrap import style. This line imports the style class from the ttk bootstrap module. TTK Bootstrap is a third-party library that provides additional professional theme styling options for tkinter applications. Basically, after found this module, my interest increases designing tkinter application. From fpdf import fpdf. This line imports the fpdf class from the fpdf module. FPDF is also one of my favorite third-party library that allows the generation of PDF documents very nicely. My personal recommendation to use in your future projects. Both of these third-party libraries are dynamically help to look your app professional. Overall, the code sets up the necessary imports and dependencies for creating a GUI application using the tkinter library, along with additional modules for working with databases, generating random numbers, handling files, and creating PDF documents. The class called label input, which is a custom widget for combining a label and an input field together in a tkinter GUI application. Let's go through the code and understand its structure and functionality. The label input class inherits from tk frame, which means it's a custom widget that extends the functionality of a tkinter frame. The init method is the constructor of the class. It initializes the label input object and sets its initial state. The parent argument is the parent widget in which the label input widget will be placed. The label argument specifies the text to be displayed as the label for the input field. It is an optional argument with a default value of an empty string. The input underscore class argument specifies the class of the input widget. It is an optional argument with a default value of TTK, entry, which represents a standard tkinter text entry field. The input underscore args argument is a dictionary of additional arguments that will be passed to the input widget's constructor. It is an optional argument with a default value of an empty dictionary. The input underscore var argument is a tkinter variable associated with the input widget. It is an optional argument with a default value of none. The label underscore args argument is a dictionary of additional arguments that will be passed to the label widget's constructor. It is an optional argument with a default value of an empty dictionary. Quargs allows any additional keyword arguments to be passed to the label input widget. The input underscore args and label underscore args variables are set to their respective arguments if provided. Otherwise they default to an empty dictionary. The self variable attribute is set to the input underscore var argument. This attribute holds the tkinter variable associated with the input widget. This block of code checks if the input underscore class is one of the special tkinter button classes. TTK check button, TTK button, or TTK radio button. If it is, it means that the input widget is a button-like widget, and the label and variable are set accordingly. If the input underscore class is not one of the special button classes, it means that the input widget is a text entry field. In this case, a label widget is created, and its text is set to the label argument. The label widget is then placed in the grid layout at row 0 and column 0. The input underscore args dictionary is updated with the text variable key set to the input underscore var argument. The input widget is created using the input underscore class in the updated input underscore args dictionary. It is then placed in the grid layout at row 0 and column 1. The self column configure 0 weight equals 1 line ensures that the first column of the label input widget expands horizontally to fill any extra space. The get method retrieves the value from the input widget. If a variable is associated with the input widget self, variable is not none. The value is obtained using the associated variables get method. If the input widget is a TK text widget, the entire contents of the widget are retrieved using the get method with the range 1.0 line 1. Character 0 to TK, end of the text. If none of the above conditions are met, i.e., there is no associated variable and the input widget is not a TK text widget, the value is obtained directly from the input widget using its get method. The set method is used to set the value of the input widget. If the associated variable is a TK Boolean var, the value is first converted to a Boolean using bool value and then set to the variable using its set method. If there is an associated variable other than a TK Boolean var, the value is set to the variable using its set method, along with any additional arguments and keyword arguments passed to the set method. If the input widget is a button-like widget determined based on its class name ending with button, the selection state of the widget is set based on the Boolean value of the value. If value is true, the button is selected, otherwise, it is deselected. If the input widget is a TK text widget, its contents are cleared using the delete method with the range 1.0 to TK, n. And then the value is inserted at the beginning of the text using the insert method with the range 1.0. If none of the above conditions are met, it means the input widget is a text entry field. In this case, its current contents are cleared using the delete method with the range 0 to TK, n. and then the value is inserted at the beginning of the field using the insert method with the index 0. Overall, the label input class provides a convenient way to create labeled input fields in a tkinterg way. Application: it handles different types of input widgets, such as text entry fields and buttons, and provides methods to get and set their values. The code creates a form for entering invoice data using the tkinter library in Python. The invoice data form class is defined, which inherits from the tk frame class. The column_defs dictionary defines the column configuration for the form. It specifies the labels and widths for different columns. Some default values are defined for width, minimum width, and anchor. The init method initializes the invoice data form class. It takes a parent argument, presumably the parent widget, along with any additional args and *quargs that can be passed to the superclass constructor. Within the init method, an empty dictionary called inputs is created to store the input fields of the form. A frame called invoice form is created as a child of the invoice data form instance. Several input fields are created using the label input class, which is not shown in the provided code. Each input field is associated with a specific label and input variable. The created input fields are then added to the invoice form frame using the grid geometry manager. More input fields are created and added to the invoice form frame. The fields include city, contact person, and phone. Each input field is associated with a label and an input variable. The input fields are placed in the invoice form frame using the grid geometry manager. The invoice form frame is packed inside the invoice data form instance, filling the horizontal space and expanding vertically. A TTK tree view widget called product tree is created as a child of the invoice data form instance. It uses the column definitions from the column_defs dictionary. The product tree widget is packed, filling the horizontal space and expanding vertically. It also binds the button release event to the select method. A loop is used to configure the headings and columns of the product tree widget based on the column_defs dictionary. A frame called product form is created as a child of the invoice data form instance. An input field for the product name is created using the label input class and added to the product form frame using the grid geometry manager. A horizontal separator is added to the product form frame using the TTK separator widget. It is placed in the first row and second column to adjust extra space sometime you need to think beyond the box to cover or adjust spaces like this. An input field for subtotal is created using the label input class. The input field is set to read only by passing state read only as the input_args argument. The field is placed in the first row and third column of the product form frame. An input field for unit price is created using the label input class. The input variable is of type tk, int var. The field is placed in the second row and first column of the product form frame. Another horizontal separator is added to the product form frame. It is placed in the second row and second column. The padx argument is set to 45 to create a larger gap between the separators. An input field for VAT is created using the label input class. Similar to subtotal, it is set to read only. The field is placed in the second row and third column of the product form frame. An input field for quantity is created using the label input class. The input variable is of type tk, int var. The field is placed in the third row and first column of the product form frame. Another horizontal separator is added to the product form frame. It is placed in the third row and second column. An input field for total is created using the label input class. Similar to subtotal and VAT, it is set to read only. The field is placed in the third row and third column of the product form frame. The product form frame is packed, filling the horizontal space and expanding vertically. The autofill method is called. The purpose of this method is unknown without the complete code, but it likely populates some fields with default values or performs some initial setup. A frame called left window is created as a child of the Invoice dataform instance. Images for the buttons are loaded using the TK photo image class. 4 buttons are created using the TTK button class. Each button has text, an image, and a command associated with it. The buttons are placed in the left window frame. The left window frame is packed, filling the horizontal space. The code snippet includes 2 methods, exit and select. The exit method is called when a button is clicked, and it calls the destroy method on the app object, presumably to close the application. The select method is called when an event, such as the button release event, occurs on the product tree widget. It retrieves the selected item from the product tree widget, extracts the values associated with the selected item, and sets the corresponding input field's product name, unit price, and quantity using the set method of the respective input fields. The code also deletes the selected item from the product tree widget by getting the selection using self, product tree, selection and deleting the corresponding item using self, product tree, delete using value X. Please note that the app object and the product tree widget are assumed to be defined elsewhere in the code, as they are referenced in the methods. The database method is responsible for establishing a connection to a PostgreSQL database demo, DB, creating a cursor object, and executing a SQL statement to create a table named Involist if it does not already exist. The Involist table has columns. The create table method first calls the database method to ensure the database and table are set up. Then, it retrieves values from the input fields, such as invoice no, date, buyer name, etc. Finally, it executes an SQL statement to insert the retrieved values into the Involist table using the cursor execute method. The commit statement is used to commit the changes to the database. The save method you provided performs several tasks. It calls the create table method to ensure the database table is created and populated with the necessary data. It generates a file name for the CSV file based on the current date and time using the datetime.now function. The file name has the format. It checks if a file with the generated file name already exists using the OS path exists function, and assigns the result to the new file variable. It defines a list called details that represents the header row of the CSV file, and a list called rows that contains the values from the input fields. It opens the CSV file in append mode using the generated file name and creates a CSV writer object. It writes the details list as the header row and the rows list as a data row using the CSV writer write row method. It iterates over each row in the product tree widget and retrieves the values associated with each row. It writes each row of values to the CSV file using CSV writer write row. It calls the reset method to reset the input fields and clear the product tree widget. Note that there are commented out sections in the code, such as writing to a file named data.csv. These sections are not executed. In the current code snippet, the code snippet includes several methods: PRD clear, autofill, add product, and reset. The PRD clear method is responsible for clearing the input fields related to product details, product name, unit price and quantity. It sets their values to empty strings. The autofill method performs the following tasks. It retrieves the current date and time using datetime.now and formats it as a string. It sets the value of the date input field to the formatted date and time. It generates a random number between 100 and 999 using randomRange. It sets the value of the invoice no input field to a string that combines the generated random number with the strings INV and XYZ. The add product method adds a new row of product details to the product tree widget. It retrieves the product name, unit price and quantity from the input fields. It then clears the input fields using the PRD clear method. It calculates the subtotal, VAT, value added tax and total based on the provided unit price and quantity. It inserts a new row with the product details and calculated values into the product tree widget using the insert method. Finally, it updates the subtotal, VAT, and total values, displayed in the input fields based on the data in the product tree widget. The reset method is responsible for resetting the input fields and clearing the product tree widget. It sets the values of all input fields to empty strings using a loop over the inputs dictionary. It deletes all rows from the product tree widget using the delete method. Finally, it calls the autofill method to autofill the date and invoice number fields with new values. Please note that the code assumes the existence of a dictionary called inputs that maps input field names to their corresponding widget objects. The code defines a class called InvoiceList that inherits from the TK frame class. The InvoiceList class has the following attributes. Column_defs, a dictionary that defines the columns of the TreeView widget. Each column is represented by a key-value pair, where the key is the column identifier and the value is a dictionary containing properties such as label, width, anchor and stretch, default_width, default_min-width, and default_anchor. Default values used for column properties if not explicitly defined in column_defs. The InvoiceList class has the following methods. In it, the constructor method initializes the InvoiceList object. It sets up the layout of the frame, creates a TreeView widget with defined columns and a scroll bar, and configures the column properties. It also calls the populate_invoice_list method to populate the TreeView with data. Populate_invoice_list. This method is responsible for populating the TreeView widget with data. It establishes a database connection. Assuming the invoice data form, database method is defined elsewhere and executes an SQL query to fetch data from the InvoiceList table. It then iterates over the fetched data and inserts rows into the TreeView widget using the insert method. Please note that the code snippet assumes the existence of a cursor object, which is likely defined elsewhere in the codebase. Additionally, there are commented out lines in the code, such as self, TreeView, delete self, TreeView.get_children, which might be used to clear the TreeView before populating it with new data. The code snippet defines a class called GenPDF that subclasses the FPDF class. This class is used to generate an invoice PDF document based on the provided information. The GenPDF class has the following attributes. Customer_name stores the name of the customer for the invoice. Invoice_number stores the invoice number. Invoice_date stores the invoice date. Items stores a list of items in the invoice, where each item is a dictionary containing the description, quantity, and price. Subtotal stores the subtotal amount of the invoice.VAT_rate, stores the VAT, value added tax, rate for the invoice. The GenPDF class has the following methods. In it, the constructor method initializes the GenPDF object and assigns the provided values to the corresponding attributes. Header. This method is called by the FPDF superclass to generate the header section of the PDF. It sets the font and adds the title invoice to the header. It then adds the customer details, including the customer name, invoice number, and invoice date. Footer. This method is called by the FPDF superclass to generate the footer section of the PDF. It sets the font and adds the subtotal, VAT, and total amounts to the footer. The subtotal is displayed as is. The VAT amount is calculated by multiplying the subtotal with the VAT rate, and the total amount is calculated by adding the subtotal and VAT. Generate. This method generates the PDF document. It starts by adding the items to the invoice. It iterates over the items list and adds each item's description, quantity, price, and total amount to the PDF. After adding the items, it inserts a line break and adds a thank you message. Finally, it outputs the PDF document with a file name based on the invoice number. To use this class, you would create an instance of GenPDF with the required information, such as the customer name, invoice number, invoice date, items, subtotal, and VAT rate. Then, you would call the generate method to generate the PDF document. The resulting PDF file would be saved with a file name based on the invoice number. The code snippet defines a class called Invoice PDF that inherits from the TK class, which represents the main application window in tkinter. The Invoice PDF class has the following methods. In it, the constructor method initializes the Invoice PDF object. It sets up the main application window by setting the title, defining the style, and disabling resizing. It also creates a label at the top of the window with the text PDF invoice and an image. Logo. The main content of the window is divided into two frames, main window and from window. The from window frame is an instance of the Invoice data form class, and the tree window frame is an instance of the invoice list class. These frames are packed and placed on the left side of the main window. The Invoice PDF class also contains a conditional block at the end of the code if name equals main that creates an instance of the Invoice PDF class and starts the tkinter event loop by calling the main loop method. To use this code, you would need to define the Invoice data form and invoice list classes shown in the provided code. Snippet in. Provide the necessary resources such as the logo image for the GUI elements to work correctly. Once you have defined those classes and resources, you can run the code to launch the PDF invoice application window. I hope you have now clear understanding about the app, and my explanation about this app gives you basic idea about how to create beautiful or professional looking app. With our previous explanation about calculator and PDF invoice app, we now move to next step, towards the ProShop app. If you like my efforts, please subscribe to my next lectures, and please feel free to provide me your feedback or suggestion. If you need me to improve,